All right, hello, good evening, everyone, and welcome to MSD's 2022 Water Quality Forum. My name is Laura Boyd, and I am with the environmental team here at MSD, and I'm going to be moderating a forum this evening. This is my first time hosting an in-person and virtual meeting at the same time, so I just ask for your patience. And for everyone here in person, just a few housekeeping things. The restrooms are just out the door and across the hall, so feel free to get up and go anytime. And then for everyone attending virtually, we have muted your lines. So if you have questions or are having technical difficulties, our behind the scenes staff is there to assist you and answer your questions. So before we get started, I also just wanted to remind everyone that after our presentations, we are going to do an open forum. So I just ask that you hold all of your questions until that time. And then we have a microphone available and somebody to assist. So the microphones that we have will also present to the folks joining us virtually. So again, if you have questions, just jot them down, take a note, and we'll ask those of the group at the end of the presentations. So with that, I'm going to go ahead and turn it over to our director, Diana Christie. She's going to give us a welcome.
Thank you, Laura. Good evening, everyone. Thanks so much for coming down here, those of you that made the trip in person and the staff of MSD. So thanks for helping put this together, the 2022 Water Quality Forum. It's been a few years, so I'm really excited to be here tonight and have you all be part of this. So I would like to acknowledge and thank our partners, Mill Creek Alliance and Hamilton County Conservation District, also Cooper Creek Collaborative. All of those efforts, tireless efforts of those groups really have helped improve the quality of the Mill Creek and its tributaries. You're going to hear more about that tonight. Also want to thank the leaders and staff of MBI, Limnotech, and Rick Record for their support of MSD's efforts to have a positive impact on Mill Creek and to help us share that story with all of you tonight. And we think it's a great story. So as you'll hear this evening, MSD and these partners, we're all taking actions across the Mill Creek to improve stream health, and we're seeing results in the data. And more importantly, we're seeing results in the streams themselves. These are very encouraging. So I don't want to steal anyone's thunder. I'm not going to get into the details, but you're all going to hear tonight how the Mill Creek is rebounding from centuries of neglect, and it's on the journey toward recovery. So the work you all do and we all do matters, and it is having an impact. And before I hand it back to Laura, I do want to stress the Mill Creek is a watershed that's shared. It's a shared resource, but it's also a shared responsibility. And it will take all of us in this room and all of us that are connecting virtually to work together to address not only the Mill Creek, but all of the regional water quality challenges that we face. So I'm really glad we can all be here and have this conversation tonight. Thank you for coming, and kick it back to Laura. Thank you.
Thank you, Diana. And I'm really excited. We, with the help of our communications team, we put together a short video that kind of highlights the forum and the reason why we're here tonight. So I'm going to go ahead and Eric. Well, this is a preview of our other exciting thing, which is our story map. All right, we ready for the video? Okay.
The Metropolitan Sewer District of Greater Cincinnati, MSD, collects, treats, and manages wastewater from across Hamilton County, protecting the environment and public health by returning clean water to local rivers and streams. Most of Cincinnati and the older parts of Hamilton County use combined sewers, which carry both sewage and stormwater in the same pipe. During heavy rains, combined sewers can fill up with too much stormwater and overflow into the nearest stream or river. MSD is working to reduce or eliminate sewer overflows through a multi-year and multi-million-dollar wet weather program. Much of this work has focused on the Mill Creek and has contributed to improvements in water quality. Highlights include a storage and treatment facility in Reading at SSO 700 that reduces overflows into the Mill Creek, an underground CSO storage tank in the Wooden Shoe community of Winton Hills that reduces overflows into Kings Run, a tributary of Mill Creek, and the Lick Run Greenway, a green infrastructure project in South Fairmont that reduces overflows into the Mill Creek by collecting stormwater and carrying it directly to the Mill Creek, keeping it out of the combined sewer system. Addressing water quality is a regional challenge. In addition to MSD, other organizations in Hamilton County are contributing to improved water quality in the Mill Creek. The Cooper Creek Collaborative is helping mitigate the impact of flashy urban flows in Cooper Creek, a tributary of Mill Creek. The group has established a 1 square mile demonstration watershed where they are installing projects focusing on naturalizing flow patterns in the creek to reduce erosion and restore habitat. These projects have included retrofitting and enlarging stormwater detention basins that feed into the creek, building rain gardens, planting trees, and installing natural log jams in the creek to slow down flows and improve habitat. The Mill Creek Alliance is working to mitigate low-head dams in the Mill Creek. The dams are typically concrete structures that protect a sewer or other infrastructure. With vertical drops of up to 5 feet, the dams block the movement of fish and impact reproductive cycles. The dams are mitigated by installing rock riffles on the downstream side, allowing fish to migrate upstream. There were once more than 20 low-head dams on the Mill Creek. By next summer, only 4 will remain. To date, MSD has eliminated nearly 2 billion gallons of sewer overflows annually into the Mill Creek and a total of 6 billion gallons across Hamilton County. The Mill Creek was once named the most endangered urban waterway in North America. It's now on its way toward recovery.
All right, thank you, Eric. So again, I just wanted to thank our communications teams, help with putting the video together, and our partners, Dave and Adam, with helping with the footage. So next I'm going to turn it over. Oh. Thanks. So at this time, I'm going to turn it over to Reese Johnson, our Superintendent of Compliance Services, to present on innovation and technology.
Thanks, Laura. Oh, yeah. Use both hands here. Good evening. Thanks for coming, and I get to talk a little bit about the fun things and very innovative things MSD is doing, in addition to some of the things you've already heard, and you'll hear a lot more later from our partners about the cool things they're doing. But let's start off here at MSD. Many of you are very familiar with the outfall-specific structures and controls that we have in the Mill Creek, right? SSO 700 storage treatment facility. Laser pointer, it doesn't work. I'm sorry. So I'm kind of pointing. We have real-time control facilities at several of our CSOs, right? And those of you who've been indoctrinated in the Mill Creek Yacht Club, right? Have gone up and seen these from the business end, shall we say? But what you may not know about is some of the improvements we've done to those facilities using technology, some innovative techniques to make those even better than they were originally designed. Apologize, these are a little slow, a little small, but this is a picture of the CSO 5 outfall gates. It's one of 4 real-time control facilities we have on the Mill Creek. We did a study on them after we put additional telemetry on them. What the telemetry was our ability to talk with that facility because it was remote, right? So we put telemetry on and we've improved their performance from what they did before. First, by just being able to see what their status was so our crews could react to them and maintain them better, we improved their performance by 15%. And then in the second year, we added control capabilities to those facilities remotely, and that improved their performance by 33%. And we were capturing 33% more flow than they had been in previous years. So we're really excited about adding telemetry to make an existing asset even better. Another one. There we go. This is a screenshot from our relatively new wet weather SCADA system, which enables us to see inside our collection system and see what's happening. And the graphic on the left is a particular portion of the Mill Creek Basin. You may not recognize it, but this is where Mitchell comes in and Ross Run. These are all CSOs in that general area. What this graphic shows is that the interceptors, gray and black, one's full and one's not. Meanwhile, I think intuitively you can see that we have all these red boxes. Those are bad, right? Those are CSOs going off while there's capacity in there. But we have a couple facilities that you know about, Mitchell Avenue and the Ross Run real-time control facilities that were designed to reduce those overflows, and they are. But what's even better is that we've put market-based controls in the programmable logic controllers that control these facilities using machine learning, so that these two facilities now perform better because they're essentially talking to each other through the sensors, so that they are sharing the interceptor capacity and deciding which one goes into which interceptor at what time. So we're able to maximize our capture, again, by adding some electronics, some innovative technology on top of existing assets. And that reduces our overflows. And typically, we've quantified that as 60 million gallons. And we're seeing even more than that in a real rainstorm. Here's another example where we've maximized what we can capture. We're also trying to minimize what's going in, and we do that through prediction. We're now pulling in predictive rainfall to our wet weather SCADA system and tying that into facilities that we've installed across the basin. This one here is in the CSO 12 basin. This is CSO 12 down here. The red area is the watershed it drains. This is UC's campus, Burnett Woods, and then down under the highway and all the railroad tracks and such. So it's CSO 12 all the way down to the basin, all the way up here. So things that are up here affect what's happening down there. Well, University of Cincinnati, has done a lot of development in the last 10 or 15 years, has been putting in underground storage tanks to capture stormwater as part of their development. And here's a picture of one. It's way up here, it's right in the middle of their campus. And we partnered with them and said, you know what, this stormwater basin, way up in the basin, if we could control that a little bit, we could reduce overflows all the way down at the river. And we've made it work because we're providing them predictive rainfall. So we know if, hey, it's about to rain and we need to dump the tank because it's full of water already, we get that out of the system before the rain comes, or vice versa, we can slowly let it out or wait and hold it until the storm has gone by and then let it go out. And the benefit has been that we've demonstrated that, it's a weird metric, but per inch of rainfall, we capture more. But what we're showing is that at the Mill Creek, about 5 million gallons less per year go into the Mill Creek. So we're minimizing by keeping water out and up. Another example, using technology, but this is a partnership we have with one of our commercial customers, and we're looking to expand this to other commercial customers. This is another screenshot from our wet weather SCADA system where we're collecting all this data, and we see right here when the blue line, which is the level in the sewer, goes over the red line, which is the overflow point, that the sewer is starting to overflow. And we've done everything we can to keep that from happening, but it's happening, and it does happen. But automatically, our SCADA system sets a condition called restricted conditions. It then sends a signal remotely out to this customer's property and says, oh, we're in restricted conditions. We can no longer accept your discharge. And we send them a text, as well as a text to ourselves and our managers and our operators to know that we're going to change operations into restricted conditions. And this high strength waste no longer just gets put into the sewer where it could potentially overflow here, and instead is trucked all the way down to the plant. Now we're able to do that in real time and do that dynamically. So they don't have to truck more than they have to. We don't want to put trucks on the road if we don't have to. But we also don't want it popping out of a CSO or an SSO or anywhere and getting into Mill Creek. So this allows us to make sure that highest strength stuff gets treated. Another thing we've been able to do is elimination. And this is through what I call awareness. Once again, a screenshot from our wet weather SCADA system over here on the left is representing our SSO 700 facility and the fact that we are having sensors downstream and upstream of that facility now, miles and miles away. And the data from all those sensors are fed back up to the storage and treatment facility at SSO 700. And we did that to reduce overflows, right? Because that facility is way up in the basin, in the Mill Creek Basin, and it's reducing overflows. But what it has also done is virtually eliminate sanitary sewer overflows from outfall 700. Virtually eliminate them because we're able to tell what's going on downstream in the CSO area and what's happening upstream in the separated area and separate those two and get them into the wet weather facility and treat them to the extent that we can there. And essentially eliminate sanitary sewer overflows from above. We're pretty excited about that. It's capturing a lot of CSO and eliminating SSO. Last is some validation, and this should bring you hope. It is still just data, and we're going to see better data from the actual streams shortly, but I don't get to play in the streams. Some of you guys get to play in the streams. I just get to play with electronics and models. So very recently, we wrapped up a comprehensive monitoring effort for the entire Mill Creek Basin. We spent over a year and a half flow monitoring it, analyzing the data, putting that through our models. And we were really excited to see that when we crunched all that through, that we were able to reduce overflows to the Mill Creek by 1.9 billion gallons. We actually were able to over control. We did better than we were aiming for. We were aiming for 1.6, 1.7 billion, and we got 1.9. It's really exciting. We're really proud of that. It's not the end of the story, and it's also not what's happening in the creek, which we'll see shortly is the data where it really matters in the creek. But this is really encouraging, and it helps us all continue to stay focused and excited about these improvements and what we can do. I think that's it. Laura, thanks.
Thank you. All right. Thanks, Reese. At this time, I'm going to ask Chris Hall to go ahead and let us dig into the weeds on the bioassessment and MSD's water quality program that we've been doing over the years. So,
I'm gonna hold two things. Well, there I am on the side of the creek, and actually Sycamore Creek, but I had to bring my own chair and my own walking stick. My age is catching up with me. So Laura, by the way, is my replacement on this project. So you all should meet Laura, and she should meet you and take advantage of carrying this forward. But let's see where we got next. Like the side button? Oh, okay, it's a side button. All right, I got that now. Well, we've been at this for a while, and you can see the Ohio EPA, for whatever reason, actually probably very good reasons, burdened us with this project to do this environmental sampling in the stream, which we did. Check that box for quite a bit of time, rather box checky. And then in 2011, we upped our game and brought in Midwest Biodiversity Institute to do a real stream assessment. And so we invested in a baseline study in all of the streams in our area, particularly the ones that were impacted by our CSOs, and we have a baseline report from 2011. And we went on and did again in our next permit cycle. We went to 3 of our streams and went our next permit, and we've been to Mill Creek, which we're talking about, and we were in the Little Miami this field season, so we'll talk about that next year. And then we'll go back again to our Ohio River tributaries, which will be Muddy Creek and its neighbors and a bit of Taylor Creek. So more ahead. So what is a bioassessment? This is the in-stream monitoring that's required by our permit. So it's a systematic assessment of the aquatic resource using biological indicators and chemical and physical indicators in a supporting role. Achieving a tiered aquatic life use, which might be unique in Ohio, but Ohio has tiers, and we'll sort out what they are, holding towards a goal of a biocriteria. So we'll talk about chloride later, but if you want to know what chloride is, you can grab a sample, take it to the lab, and they'll give you a number. If you want to know how the fish are doing, that's not how it's done. So we'll get and you want to know if you're in compliance, then give you a number for chloride. For fish, all right, we got to work harder. So here's the methodology to use. You can see in the center, top center, the fish biologists are in the creek with their floating raft, which is a generator, so they can electro fish, so stun the fish so they can capture them, and then bring them into this device, and they'll stand there and sort them out by species and size and get a good collection of what fish are there. In the top right is the some macroinvertebrate hotel. You build this little plates, attach them to a concrete block, put a few dozen of them out there, and then come back 6-8 weeks later, and you got a whole boatload of them. And so there's a method to capture them and bring them back into the laboratory for identification. And then the bottom right, we're just collecting chemical samples in the usual sort of way. In the bottom middle, we're using a data sonde. We'll put that in the stream and keep it there for a week, 24 hours a day, to get the trend of the stream and its diurnal dissolved oxygen and temperature and those kind of parameters. And then finally, there's an assessment of the habitat using a format to determine the physical characteristics of the stream, and that also yields a value. So the bioassessment provides us with an assignment, affirmation of the appropriate aquatic life use. So whether it's warm water habitat, etc. And so we've determined that for all of our streams using this method. It also determined its status, whether it's attaining or impaired. And it will show the changes over time, which is, we'll look about that today. So this is our third visit through the Mill Creek. And so we will be able to get a good view of the trend. So in this, objective 1, we're looking at the aquatic life use attainment, and we get the hierarchy that can be applied to the water body, what it can actually attain. And some of them have a lower limits because of their ability to attain. So we have exceptional warm water habitat in our neighborhood. We have a lot of warm water habitat, and we have some modified habitat, and probably the bulk of it is a primary habitat. So we'll make our assessment here, looking for the status and the causes of impairments. And then with that knowledge, then we can make our plans and prioritize what we're going to do where. So we have a something lost in the translation. Well, this is even smaller. So strain your eyes, but you can see the big yellow is going to be the urban pollutants that are the predominant impact on this. And on the right side is just flat out everywhere what it is. And then there's a new method that's being applied by MBI, and maybe we can talk about that later in the forum, where they're weighting it. And so weighting it so those portions of the reaches of the stream that are most impacted by these urban related pollutants with chloride, total dissolved solids, etc. We have in the report, and this is straight out of the report, some commentary here, so please go find the report. There's a lot of detail on this. You can see on the left are all the reaches that we evaluated, and one that met the full attainment, partial attainment, non-attainment for aquatic life. And then on the right side, you can see our recreational attainment. And I should warn you, this is not an E. coli study. So this is E. coli that we captured while we're out in the field. But you can see that we're not really attaining anywhere where you can be swimming in the Mill Creek. But we are, for the most part, acceptable for recreational canoeing, fishing, that sort of thing. And we're looking at the bottom of the Mill Creek, working our way up from the Ohio River, which is at the very bottom. We have you'll see that And the chart there, this is mostly a modified warm water habitat. So where the stream is yellow, orangish, that's modified habitat. And we're finding ourselves in full attainment. Most of the reach through there. So it's a standards a little bit lower, which helps. But we have a full fish access to the Ohio River, so we got a lot of good fish, and our macroinvertebrates are content as well. We move up into our middle of the South Branch here. We have around the industrial heartland of St. Bernard, where it's highly channelized. So if you go there, the concrete wall got a little channel in it, and we got some red dots there because it's just not good habitat for growing anything. And then we move up, we get about middle of the watershed there, and where the stream turns green. And now we're in a warm water habitat. We left the channelization, and now we're getting more naturalized than what we do. It's also very close to where we've mitigated some of those low head dams, which are, our fish don't jump, so they need to swim up the riffles to get into the upper reaches of the creek. And we are achieving that, and our fish scores are reflecting that. You can see it in the data. Go all the way up here into the Reading, Sharonville, the stream habitat here, and particularly noticed on our Cooper Creek, we're having our partnership with the Conservation District and Adam Lehman. So Adam's certified to do the same work that our contractor's doing. So he was out there collecting the samples that were needed. And we found that some remarkable habitat was up there. And you saw some of the pictures in the video, and you'll see more later from Adam, that he is making some changes in the habitat there that is driving the change in this area. So we're happy all about that. Finally, we're leaving the county here because my map kind of stops giving me detail right here. And then you're up into the next county. And so we're receiving water. Matter of fact, most of the water in the stream is coming out of the Butler County Regional Treatment Plant. And so they should get some kudos for a good bit of the improvement in the stream, for improvements they made in the past. So we're happy about that. But we will see that there are still some challenges ahead. Oh, and by the way, there's maps, there's a handout for everybody here, and we'll put them in the chat. And I've been informed by our experts that I have a couple of numbers that aren't quite right. So we will email them to you. So you'll get the full updated version. So these trends that we're finding here using this technique of the area of degradation value, it's kind of a shorthand to summarize all this data that you have into fewer graphics. And this will show you that the degradation in the creek in 92 was extensive. It was everywhere. Nowhere was attaining in 1992. As we move up through the years, we have more stream miles attaining fish. And that is our kind of our lagging indicator. So the fish will come along and they're on the upswing. They face a challenge, you'll see in the next graph, which is fish. It's the median index of well-being, which kind of determines their productivity, the size and the range of the fish, the diversity of fish, and that's hard, and that's an area we need to work. But we can show in our bugs here. So on the macroinvertebrates, we are hitting it everywhere. Everywhere we went, we have good bugs, and that is really an indication of the lessened pollutant load in the streams from us. This is the leading indicator. So where the bugs are happy, we are doing what we need to do. And so we're really pleased with our part. We've also had our partners have reduced the toxic load coming from landfills that were along the Mill Creek and our industrial customers. So the community has really made this difference, and this is our leading indicator. And then final chart is just a summary of all of that. So you can see the progress we've made over the years, mushing all the data together into one trend, and we've kind of flattened out. And so we look and some of that is just related to how well we are mitigating dams and how well we are managing the flashiness of our stream. And well, so it takes you into a lot of data, and these read the reports, it's all in there. But if you start looking at a trend across here, so this is a 5-year, the first year, 11, 2016, 2021, and the difference between those at 10-year period. So we've only had one site that declined, which is why I circled there. Gone from full to partial to non-attainment. Everywhere else, we're in the green, or we're heading steady at yellow. Which, if you're full attainment every time, that's all there is. So we're there in a lot of places, and that's really good. So we know where that place is. It's in the that concrete channel we talked about, downstream of one of our industrial dischargers. And we have the next part where we had a little bit of a decline is way up there by the Butler County plant. So more data mushed together here. Just look at the colors in the range of the 10-year plan. We've got a lot of green. We have some positive numbers, not a lot of red, and that's meaning that over 10 years things are improving. Same thing, only different. And here is an area where we face a challenge. And this is with chlorides, total dissolved solids, these urban pollutants. This is, I think, is the only pollutant load that is getting worse since 1992. So there's things about that. Chlorides have a lifespan in the stream. Once they're in, they kind of don't get washed away. So once we stop putting them in, they'll hang around a while, and they can have an impact on fish, in particular in the macroinvertebrates. So chloride is kind of in its TDS, and those things are in our future. So we have another more technical session coming up. We're arranging on our CSO severity study with our vendor Limnotech. So Limnotech is our water quality modeling program manager. So we toss all the innovation things that we're doing with water quality and with them, and they bring in subcontractors, and we are doing quite a few things. This in-stream monitoring will be managed by them to bring in more modeling into the effort. They built our story map, which I'm going to show you next. I do watershed modeling and planning, and the RDI&I, which is rainfall derived inflow and infiltration. So they're doing some research on that, and also did our COVID and the wastewater studies. They managed that for us, and doing some real-time water quality monitoring. So severity analysis helps us look at the actual pollutant load in the CSO compared to the stormwater that's in it. So they might have some big overflows, but the actual sanitary load is quite small. And we have other ones where the sanitary load is large relative to the overflow. And so that might drive us to look closer at storing there and doing some other things. So it's a really valuable study, and we're working to integrate that into how we do business. So now we're going to switch to our story map. At some point, Laura's going to get the hook, because this is quite an amazing tool that's come to us, and I might spend way too much time on this. So I need a mouse to drive that. Story maps are new to me, and so I'm just kind of marveling at what this thing can do. It's kind of like a PowerPoint and a map. And so once you get in here, you can scroll, and as you scroll in, the map is running in the background with the text that we're providing. So this is a really super cool tool. We're just developing it. We're just getting it out and amongst ourselves. So it's kind of like brand new today. So we have we're still going through some tweaks and to get it out to the rest of you, but that's our goal, is to get it approved within our organization and ready for prime time and share with you. And you can delve into this quite a bit. So this is just a preview of the things that it can do, and the shows you about our treatment plants. Since it's a ring. All right. Well, yeah, I know. I'm trying to get it to move at all. All right, so I gotta get the mouse in the screen. All right, tech guy, thank you. Well, that's not possible. So there's history on here. Yeah. Didn't I mention the part about how we got to do the things, that match my frame? So with the, Eric, please take over the mouse and scroll down the screen for me. So there's a bit of history here. It goes into, you can see our treatment plans. When you click on one on the side, you'll see photos of that and more detail. But that's not really the fun stuff. Go up to one of our tabs and hit our wet weather facilities. And we'll show you the CSO5 that we have in here. You can click on that. It'll show you where it is and then begin to give you some pictures about this. So this is just the beginning of the pieces that we're putting together and understand its capability to make it a very good communication tool. So if we can hop over to overflows. We have all of our sewers mapped on here, and let's skip that and go to our real-time monitoring. So we're developing internally. We have this amazing tool. It's just changed how we do our work, and with real time showing on the map what is overflowing and what's active. And so a lot of things, there's a lot of sensors out there, and sometimes they go a little wonky. So it alerts us to that, and we can be right on top of them, getting the sensor fixed or something that might get clogged up, and we can send a crew out to get it clean. It's really changing our dynamic and how quickly we are responding to our systems. We like that a lot. So we can go up to the water quality portion. There's Adam collecting samples in the Cooper Creek. So you have a nice quote from John Mangan here describing the real dynamic in the creek, which is the ability of folks to interact in the Mill Creek and fish well. We've got MBI does this work here. They are collecting samples in this channelized portion of the creek. We capture some good fish. Nice, that's a beautiful fish. That's a nice looking one there too. And all those invertebrates come back into the laboratory and get picked through and looked at. So there's somebody that takes a job and looks down a microscope all day, every day, day after day. I think there's probably 10 of them in our country with 300 million people. It's a rare person that can do that. So, and it takes that to discern what we need. Also, we got our habitat indexes evaluated. A lot of chemistry samples. Here's from our constructed stream, our remediated stream here that we made in Lick Run. At our baseline sampling. So in our partnership with MBI, who does this kind of work all over the place, we get all the data from all over the place that we can then bring in to use in our work here. So our baseline is disappointingly not there. Yeah. All right. Well, okay. All right. Let's do one of them. As if you click through, you'll see what we did the last season round and where we're at in the current round, but a lot of sampling locations throughout our area that help us understand our stream in relation to reference streams and other places like that. Let's move to our partnerships. We'll just skip over here. So our partners, right, yes. Yeah, so we start loading this up. You can see that it slows it down, but this will be, well, we'll move it. So our partners with Limitac, the Midwest Biodiversity Institute, Mill Creek Alliance, the Cooper Creek Collaborative, Rivers Unlimited have helped us get where we are. Let's go to our Mill Creek Basin. So we'll create a tab, a map, story map for each of our basins. So this is Mill Creek. We'll get to Little Miami next year, and we'll do the Ohio River tributaries and the other. And this is a really cool feature here that the story map provides to us. And you can just kind of take two images from different time frames and slide them back and forth and see what the difference is. So the report, there's a link to the report on here. These an explanation of these the ADVs and so you'll find that here, that explanation of what it is. A lot of scrolling. Then we can come here and find your way to when the data shows the points location shown on the map. You can then click on a location and go see more data. So when you get there, you might need to be patient, but this will be a portal to get to more and more of our data. So hopefully we can store everything we have so that you can use it for any grant writing you might need to do or any other things that you're working on where the data that we've collected in this program is useful to you. Yes, it is. Oh. No, let's go to, oh yeah, here's all our sites we did in 21, just like the maps I've given you. Let's go to featured projects and it allows us to then feature some of our projects. And in this map, using this slider, you can see the location of all the capital improvement projects we have invested in the Mill Creek Basin over these years. Lick Run Greenway, there's lots of ways to see what happened in the Lick Run Greenway. And here's another view of that. We can link to other folks' work to kind of bring it in with our partners. So we can bring in, so you can use this as a portal to get to other things related to what we're doing that our partners have been working on. And the Cooper Creek demonstration, see what we have here. Basins they put in. So, you know, a PowerPoint inside a map tool. It's SSO 700, and then we have some of our other features. I think we probably got to the end of this. I'd like it to be faster, but the and the Lowhead Dam, we're going to hear about that next. So,
Thanks, Chris. Yeah, we've been working on the story map for, I don't know, a couple months now, and it's really exciting to see it all come together. It's taken a lot of effort and also a lot of input from a lot of people. So really excited to see how that turns out, and hopefully we can make that available in the future for everyone as well. So I think to move things along, we're going to go ahead and lead into our partnership presentations, and I'll welcome Dave Schmidt with the Mill Creek Alliance to give us an update on Mill Creek.
Hey, everybody. Wow. We're going to hold that down a little lower. For those that don't know me, I'm Dave Schmidt. I'm the executive director of Mill Creek Alliance, nonprofit here in the area that's been working for 25 years or more to restore and protect the Mill Creek and the watershed. And we do that with a whole lot of partners. A bunch of you are here in the room with us tonight. So thanks to everybody who's here, who we've worked with over the years and will continue to work with. I also want to take a moment to point out members of our staff who are here tonight. Dr. Bennett Cutler, who's our Stream Restoration Program Manager. Audrey Roberts, who runs our Water Quality Monitoring Program. And Linda Keller, without whom the whole place crashes and burns, right? That runs all of our recreation programs and so much else. And a number of our board members are here tonight as well. So thank all of them for taking the time to be here. You know, Chris Hall and I'm sure Adam and others in the room are going to focus on the data, and that's all great stuff, and it's important, and we need the data to make decisions about what we do. But I'm here to share the good news. Okay, you know, think about where Mill Creek was 25 years ago. In 1997, Mill Creek was named the most endangered urban stream in North America by American Rivers. You wouldn't even have thought it possible to go fishing in Mill Creek or to find a freshwater mussel in Mill Creek. And now 25 years later, that story has entirely changed. It is amazing comeback and an amazing story. I want to share a little bit of that good news with you. And I'm not saying that our work is done. The Mill Creek Alliance has not yet worked itself out of a job, and MSD has not yet worked itself out of a job by a long shot, but the results of all of our work over the past 25 years are just truly amazing. Let's talk about that a little bit. So, freshwater mussels. 25 years ago, you would not have found any in the Mill Creek. The water quality would just not have supported them at all. And around about 4 years ago, a gentleman named Warren High, who's right there, was both crazy enough and brave enough to think that, hey, maybe we can reintroduce those to Mill Creek. And he was able to convince ODNR to do that in a couple of locations. And that's amazing that the water quality would support that in and of itself. What's really exciting to us is that in the years since, we have also found other populations of mussels elsewhere in the creek that are unrelated to the ones that Warren reintroduced. So it shows that the water quality is improving and allowing these populations to come back. And we've got a couple pictures of those up here. A giant floater, a good size one, 6 inches or so, which means it's several years old, found up in Sharonville. Another species called a fragile paper shell, which was found in the stream near the Hopple Street Viaduct. And pond paper shell, which is found on the West Fork Mill Creek in Lockland. We think there's probably others out there. We need to do some mussel surveys, but it's clear that the mussel populations are coming back and they're filter feeders. They're very sensitive to water quality. This would not be happening unless we were making real progress on the water quality. As Chris Hall just said, macroinvertebrates are now in full attainment everywhere on the creek. I mean, that's amazing from where it was 25 years ago. Macroinvertebrates, all the little critters, the crawdads and little bugs that live under the rocks, were in full attainment everywhere that was sampled on Mill Creek. And that's important because it provides food for fish and many other things. And now we're seeing that the fish populations have also recovered strongly. We're seeing bald eagles and ospreys on a regular basis where you never would have seen them before. For most of the time in recent history of Mill Creek, maybe you would see a bald eagle down at the mouth near where it meets the Ohio River. Occasionally you would see one at Winton Lake. Now we see bald eagles on Mill Creek all the time, the entire length of the stream. It's truly amazing. And obviously they wouldn't be there if there weren't fish there. And similarly, we're seeing ospreys up and down the creek. And Chris had some fish pictures. I got better fish pictures. We've got some guys that we take fly fishing on the Mill Creek. Who'd have thought even 10 years ago that you could take people fly fishing on the Mill Creek and it'd be worth their time? Also this past summer in the upper center picture, we launched for the first time a summer youth fishing program. So we had youth from all around Cincinnati who we took out 10 weeks in a row for fishing outings on Mill Creek. And we're teaching them both fly fishing and regular rod and reel fishing. Great program. They had a ball and caught a lot of fish. And then just a few other fish pictures from other places. And these are big fish that are being caught in places in Cincinnati that you wouldn't normally associate with there being good fish populations, but they're there. The bottom left is a smallmouth bass, and that was caught up in Elmwood Place. The picture in the center, largemouth bass that was caught in Carthage. And this, I'm particularly excited about this one. This is a sauger, sort of a top predator fish that was also caught up around the Center Hill area. So you've got these large, sport fish, predator fish that are obviously good size, that are finding plenty to eat in the Mill Creek, which means you've got a healthy population of smaller fish as well. So the stream really is making a comeback in this regard. And we'll talk a little bit more about the Lowhead dams that Chris mentioned, because that is probably the limiting factor why a number of our sites are still not in attainment for fish populations. So let's talk about that a little bit. As Chris mentioned, at one time there were 20 plus such obstacles in the main stem of Mill Creek. A lot of negative environmental impacts, but particularly they prohibited fish and turtles and other critters from migrating upstream. You know, even as the water quality improved and would support them, they couldn't repopulate the watershed because they couldn't get past these obstacles. So removing these barriers has a lot of ecological benefit, but it also protects MSD's infrastructure. This picture here was a lowhead dam that was in the vicinity of Solway Park on Spring Grove Avenue. Pretty good drop, and you can see when the water comes over that edge, it has a lot of turbulence. It creates a lot of erosive force, so that when we mitigate these with bring in natural rock, create a very gentle underwater lowhead dam that creates a pool at the same level as the top of the lowhead dam, that erosive force is eliminated and it actually protects the infrastructure better. This is a view of what that same riffle area looks like now. You can see that, you know, there's not that drop off there, and exciting, you know, from an ecological standpoint, because, you know, even within this channelized section, when you put in this riffle, the stream starts acting like a stream again. All of this rock is great habitat for all the little critters, and it catches sediment. It causes sediment to drop out, and you get these sandbars that are forming that also make excellent habitat. So even within a channelized section such as this, the stream can become a much healthier stream as a result of removing these obstacles. The other great thing about it is that it improves the ability or the opportunities for recreation. You know, let me go back one. You'll notice that even in a very low water situation, and these pictures were taken in September when the water in the stream was quite low, you know, we designed these riffles so that there's a low flow channel that goes right down the middle most of the time. And that allows for not only for fish passage, but also for canoeing and kayaking. And this picture was taken the same day. You know, there were two riffles about 0.7 of a mile apart in the vicinity of Solway, and both of them were mitigated. And the other effect of that is it creates a beautiful pool area between these two riffles. And so even in a low water situation, members of the public can go out and go paddling. And we want to replicate this in other areas up and down the stream. There's great access point at Solway Park. There's a beautiful ramp there. We have our eyes on several spots throughout the rest of the lower watershed where we want to do the same thing, and create great access points for the community. We're definitely not stopping where we are, as Chris mentioned, and I think in the video it mentioned that, you know, we already have grant money in hand to do a couple more of these lowhead dam mitigations. This one is at Clark Street at River Mile 12.2. That's up right on the border of Reading and Arlington Heights. So we'll be getting to that one this coming year in 2023, as well as this one. This is the next one downstream, just a couple tenths of a mile downstream from there, that the Mill Creek Yacht Club lovingly refers to as Bone Crusher Falls. It's a big drop. You can see what kind of a drop that is. That's going to have to be a much bigger riffle to accommodate that. But obviously, you know, as Chris Hall mentioned, we don't have salmon around here. You know, we don't have fish that can jump something like this. So in order for fish to truly repopulate the stream north of obstacles like that, we have to do this kind of mitigation. And it's going to have tremendous water quality benefit as well as providing for fish passage. And last but not least, I will say that we are currently pursuing another opportunity to hopefully mitigate almost all of the remaining lowhead dams in the main stem of the Mill Creek. Bennett and I are currently getting ready to submit an application to the Fish and Wildlife Services Fish Passage Program, which would, if successful, and we get that, we'll be able to mitigate 5 of the remaining ones all at one go, which would be spectacular. So, they told me I had to limit myself to 15 minutes, and I told them that was torture, but I think I've gotten that done. Thank you very much for your attention.
Thanks, Dave. And I'll just add that when Deb, Eric, and I went out to Bone Crusher Falls to get some footage for our video, there were some folks fishing out there. So they said there's some pretty large fish there, and probably because of the pool that is right before the dam. But that was cool to see. So, all right, now I'm going to hand it over to Adam Lehman with the Cooper Creek Collaborative to present on their efforts.
Thanks. Can hopefully learn from other people's struggles here. Keep this down here. I'm going sideways, right? Yep. Okay. So I'm Adam Lehman. I'm a stream specialist with Hamilton County Conservation District. I'm also the coordinator of the Cooper Creek Collaborative, and that's kind of the capacity that I'm talking in today. So I'm a watershed manager. I took this job 6 years ago and was asked to go forth and make streams in Hamilton County healthy. And so that raised an immediate question, well, what's wrong with the streams in Hamilton County? And so this is really about, how this data set that we're all here kind of unveiling today has allowed me to, to shape my program in an informed manner. And one specific aspect that I want to look at today is something that hasn't really been mentioned, but we talked a lot about the bioassessments and aquatic life use attainment. But a really useful thing that's in these reports is that if a stream is not in an attainment of its aquatic life use, then MBI did an analysis. Well, what are the causes or potential causes for that? And this is a breakdown. This does not include the new data. This is from 2011 through 2017 data for the entire county. And basically, for all those yellow and red dots on the maps that Chris showed earlier, these are the causes of biological impairment that were listed. And I noticed 2 things right away when I look at this kind of broken down between headwater streams and the larger system. The first is there's a lot bigger bars on headwater streams, right? And that's not just a relic of, okay, there's more stuff listed. Actually, if you dig in for the headwater streams that were assessed, 78% of them were in non-attainment compared to only 27% of the larger system streams being in non-attainment. And when we think about a statistic like that, I think it's important to point out that 85 to 90% of stream miles in the state are headwater streams. So on a landscape scale, we're talking about an extraordinary amount of habitat degradation and in some cases, habitat loss. The second thing I see when I look here, which kind of really informed the way that I developed the program, is there's a big winner here. Maybe a big loser is a better way to look at it. And it's something I talk about, I call hydrologic alteration. You might see that term in the report. When MBI talks about it, they talk about this blue bar here. That's base flow impacts. That's streams that are basically going dry when they wouldn't in an undeveloped situation. But if I look at this green bar here, sediment impacts, I think in a lot of cases in urban areas, I look at that as a surrogate for flashy flow impacts, right? These flashy urban flows that destabilize channels, destroy habitats, and it dumps a bunch of sediment from the destabilized channels into the stream. So taken together, we've got a by far most ubiquitous kind of cause of biological degradation in the county. But it's kind of a special cause too, in that it's also foundational. So when from a watershed restoration standpoint, we understand these functions that a stream has as hierarchical. And what that really means is when you have a foundational function like base flow or just the flow regime in the stream, if you go and implement a mitigation project for water quality or habitat, you can't fully realize the benefits of those projects unless you are also addressing the more foundational problems first. And a real easy way to think about this is if a creek is going dry in between rain events, there's not going to be a lot of fish in that creek to care about increases in improvements in water quality and habitat, right? And so, Adam, go forth and make streams healthy. The entire landscape is kind of altered, and hydrologic alterations a problem everywhere. So, you know, this brings out the question of, is this even feasible to restore the hydrology within densely developed watersheds to a biologically relevant extent? And so this is just a question of me saying, you know, how can I, you know, really move the needle in, you know, my one person shop here? And so I don't know the answer to this question, but what I do know is that an earnest attempt to address this involves working in one small area at a time, focusing on hydrologic mitigation projects until in-stream hydrologic objectives are met. And so that's this idea that all the members of the Cooper Creek Collaborative have come around this idea that we're going to do this. And so this is in the red polygon here. This is a 1 square mile area at the top of Cooper Creek where folks have said, yes, we're gonna just implement projects in this small area until we see the needle move in the creek. And I say hydrologic efforts. The goal is biological, right? But you know, the hypothesis that you can't get there until you can restore more natural flow patterns. So that's the idea. Kind of just to fly through in the limited time we have of all the ongoing projects that are going on here. The trees kind of make this map a bit of a mess, but the main thing that we've been focusing on our phase 1 of this is detention basin retrofits. We've got 10 of these surface detention basins within the watershed. And thanks to some tireless work from John Mangan and really to the credit of these landowners, we think we're going to be able to get every single one of these things retrofitted. This is the big problem when we talk about addressing urban hydrologic alteration, a landscape scale project, is that the world is private property, right? So that's one of the bigger challenges, and that's been something that's really been heartening to see how many folks have been willing to work with us on this. So that's been the main focus. You know, we've been at this thing for about 5 years now. The first 4 years, we're collecting baseline data to make sure that we can actually detect these things. And we've just really started to get the ball rolling. We've got like 7 of these things already in the pipeline. We've got a rain garden installed. We've got 344 trees planted. We got this large woody debris project, which you guys, I think, have saw some photographs of those. And I'll just point out, you know, we're talking about hydrologic mitigation, right? This is a great habitat project, but the point of these things are twofold. Induce deep scour pools. This is refuge for fish when the stream dries out, but also as a flow resistance. We're trying to slow down the velocities, therefore slow down the erosivity of these flashy flow regimes. So that's what we've been doing. A few things that are on the docket, I'll just check through real quick. We got 64% of the homes have their rooftops directly plumbed into the stormwater district, right? Or the storm sewer system. So we took this this idea from the Shepherd's Creek study. If people are familiar with that, US EPA did this study in the Shepherd's Creek area a while ago where they did what's called a reverse auction, where we say, all right, we want to pay you homeowners, let us come onto your property and disconnect your downspouts so that they can discharge onto your lawn and soak into the soil. How much are you going to charge us to do that? And we just pick the lowest bid until the money's gone. And so that's something that we're working on currently. The entirety of Cooper Creek has a sanitary line that runs parallel to it. And there are certain locations in the creek where we note that the creek is drying out despite having perennial flow upstream, perennial flow downstream when it gets in close proximity to the pipe. So I'm super excited to be able to say that we've recently got a green light from MSD to pursue funds to try to implement a pilot mitigation project to try to address this problem. This is in Bechtold Park, so we got like a 250-footish long dry span here that we're going to try to mitigate with a fairly novel approach that we're excited about. This is an approach that I haven't seen done in streams, but it has been done in other jurisdictions as a overflow mitigation strategy. So we're hoping to make some impacts on both ends there, because we do have some sanitary sewer overflows in this location as well. I had 10 minutes, David, but if you're going to ask, I'll back up. So, right now we've got some data from US EPA, right? We had this dry reach. EPA put in a bunch of piezometers, and they all show that the water is pointing at this pipe, right? And we reached out to MSD, and they put a flow monitor in the pipe. And so given the limited reach that we're looking at, it looks like, water's going at the pipe. It doesn't look like all the water that's going there is accounted for in the pipe. So the hypothesis is, think about a French drain, right? When you install a sewer, you dig a big trench, throw some gravel, put a pipe on there, cover it with some more gravel, cover it all up. It's basically a French drain, right? And so the idea is we want to excavate out in limited areas and just fill it with concrete and just create a trench dam, just like the name sounds. And so the idea is you break up that preferential flow path, it pushes the water back up to the surface. And I mentioned that this is something that had been done elsewhere for overflow mitigation projects. And in those cases, I talked to this guy who's done a lot of this in I think Alabama and Chesapeake area, and he said that they had a lot of problems where like the water just starts shooting up onto the surface and causing flooding people's basement. This is not a problem down here in this valley. We want it to come out to the surface. That is our goal. And so I'm really excited about the prospects for that. This will be a priority for the collaborative in 2023. Thank you for giving me an excuse to elaborate, David. The final thing I'll talk about is, we're focusing in the demonstration watershed here on our watershed-based projects to mitigate impervious surface. But as Dave talked about in the Mill Creek with the migration barriers, our ability to induce biological lift is going to be limited if there's perched culverts that the fish can't migrate up into the upper Cooper Creek. So we're really fortunate that the lower portion of the Cooper Creek is pretty much wide open. These are road crossings. That's what all these dots are. And the red ones are the ones that appear to be a significant barrier. So below that, we're wide open all the way down to the Mill Creek. We've got full aquatic attainment in the Mill Creek in that area. And we've got these two right here that are a priority that we're going to try to mitigate, and that'll open up, about 4,500 feet of stream and get these things up into the bottom of the demonstration watershed. So we can, once the hydrology starts to recover, we'll be able to fully realize that. I'll just kind of point out, this is the 2021 data for the Cooper Creek. And this is kind of a typical pattern you see on the landscape, right? We got full attainment down here in the lower areas, right? And we got this heavy hydrologic impacts in the upper regions. And kind of what happens is at some point you reach this critical watershed drainage area where you can overcome the stream drying out. And that's what we start to see down here. And this kind of Ronald Reagan Highway divide that bisects the watershed is really where that impact starts to be felt. But you can see this yellow area, right? This is actually a really nice, stably flowing area, but that's just where those two fish passage barriers are. So, we got 3 species of darters and like a green sunfish that exist below those 2 barriers and not above them. So that's going to be another priority coming down the line. And so with that, I'll just kind of say I keep talking about hydrologic objectives. This is something that's kind of open-ended because we don't, again, the whole point of this, we don't know what it takes to fully mitigate this problem. And so we're looking at things like, how many perennial pools, how frequent are they? What's the connectivity between them? And so we've got lots of folks from lots of different university and federal labs helping us monitor these things. We're ultimately looking at the biology, and we're trying to go from this, which is at the bottom of the demonstration watershed, to something like this, which is right after it rains. So, we like it to look like that all the time. And with that, I think that's all I got.
Thanks, Adam. Okay, so I asked you to hold all your questions to the end. So hopefully there are. Right now, I think we're a little ahead of schedule, actually. So I think we'll start with questions from the audience. So if anyone has a question, speak up. Yeah, Rick in the back. Do you want a microphone? We have a microphone. Oh, yeah, good question. We do have some people here who have volunteered to introduce themselves, and I forgot that, but sorry. Chris Yoder with MBI is here, so I'll have him come up and introduce his new director and say a few words. Yeah.
Okay, thank you. I'm Chris Yoder. I'm the research director at MBI, and I wanted to introduce Trent Doherty, who is sitting here. He won't stand up. He's our new executive director. And some of you may have known Pete Precario, who just recently he took on emeritus status. So he still comes to the office, but we're glad to have Trent with us. Trent's actually environmental attorney and was with the Ohio Environmental Council for many years. So we're certainly glad to have that capacity at MBI. Okay. So, there it is. Okay. So MBI is, we are a 501c3 nonprofit, and we're governed by a board of directors. So this is our webpage. If you want to visit it, we're in the middle of a huge revamp to make it a little more descriptive about what we do. So Trent's the executive director. I'm the research director. Allison Baylor's our administrative director. and we are staffed by both full and part-time research associates. So some of our major areas of practice, and this is Mill Creek, by the way, if you recognize where it is. So we do aquatic biological surveys all over the Midwest, New England, and the Great Lakes region. It's a lot of what Chris talked about, streams, fish, bugs. We do some amphibian and crayfish surveys, and data management and analysis and reporting as a result of that. So we do provide technical support to states and US EPA. We've done state program evaluations focused on this kind of work on at the request of EPA and sometimes the states themselves in 27 different states. And we've also, that's led to actually helping states improve their programs as a result after that. I'm getting the speed up thing here. So water quality standards, that's another policy and development. Also innovative technical support, something called an integrated prioritization system, which we have developed for here at in Hamilton County and also in Northeast Illinois, and a combined nutrient effects procedure that Ohio EPA developed. And we're using that here. If you read the Mill Creek report, you'll see that. Training, we do Ohio Credible Data Law training. QDC means Qualified Data Collector, levels 2 and 3. Adam's a great example of a level 3 Qualified Data Collector who went through the training and got his certification. And we also do citizen science as well. And lastly, kind of the theme that we operate about is a major guiding principle that called the 5 factors that determine the integrity of a water resource. And treating these independently will not solve the problem. MSD is a great example of supporting this level of science and integration. So it leads to needing, recognizing the right mix of parameters and indicators and the kind of monitoring design that you need to have a balanced management responses to multiple and overlapping stressors. So that's 5 minutes, right? Okay, good. Thank you.
Thanks, Chris. And who do we have next? Did I skip? Oh, ODNR. Is Aaron here? Yep. Sure. Or we have a microphone we can bring to you. Oh, yeah, you're halfway there. Come on down.
That line?
Yeah.
Yeah, and 2 minutes, not 5, right? Okay. I'm the Scenic River Manager for Southwest Ohio, Aaron Rourke. So I have the Little Miami, all 107 miles is designated as a state scenic river. And it's mostly designated as a national scenic river. Here's a little interesting tangential trivia question for further discussion sometime. The bit of Caesar Creek, which is still free flowing between the dam and the confluence, not state designated, but it's a federal wild and scenic river. Yep. I also have the Stillwater River and Greenville Creek. Stillwater River comes into the Great Miami and Dayton, and it originates up in Darke County, flows through Miami into Montgomery. And Greenville Creek is its principal tributary. I think a lot of people don't really know what the Scenic River Manager does. I have 3 main duties. I have an employee who is our stream quality monitoring coordinator. She just resigned. Her last day is tomorrow. So there's a job out there. She does macroinvertebrate sampling at reference sites, which have been sampled for 30 or maybe going on 40 years now on the Little Miami, Stillwater, and Greenville Creek. I think there are a total of about 25 reference sites on the 3 waterways. What she really tries to do is to recruit volunteers to do them under her supervision, so that it's not only a citizen science project with level 1 credibility, but it gets a lot more people in touch with the resource. And, even though many of us live in floodplains, our line of sight and so our awareness of rivers is intercepted by levees. And even when we drive across bridges, they have sidewalls high enough that we can't look down and see the beautiful Little Miami River. For instance, the highest bridge in Ohio, Jeremiah Morrow Bridge. You'd never know you're driving over the river. It just looks like a flat spot in the highway. Okay. One of the things we're really worried about is the collapse of the freshwater mussel biota. To give you an example, a quick sketch. I know I'm at like 3 minutes already. Mike Hogarth did the first definitive study. He did the entire main stem and the 3 main tribs, which would be, Adam, what's one of the 3 main tribs? Little Miami River. Yeah. You got an idea of another one? Next one north would be Todd Fork and Morrow, and then Cedar Creek north of that. Only one of them remains undammed. Years ago, there was a debate about damming the Little Miami for flood control. The compromise was 2 of the 3 main tribs got dammed. All right. Anyway, he did a complete survey, and he also consolidated all the anecdotal data that was known from Rafinesque and all the other naturalists in the 1800s. And he said there are about 40 species known, as I recall. He found 36 of them, I think. He came back, that was his graduate thesis in 92. He came back 15 years later as a professor, and he found 1 more species. Diversity was still there, but the abundance was down to 1/3. We hired him to do another survey in 2018. He said, well, now we have catastrophic collapse. In places where I'd find 100 individuals, maybe I found 6 of the most tolerant species. So we're really concerned about why our marquee state and national scenic river, which meets exceptional warm water habitat criteria almost everywhere, is it's failing on this one big count. Fish are great, macros are great, but the mussels they're taking in the shorts for some reason. East Fork is the stronghold, by the way, down near you. Hey, I really look forward to next year's emphasis on the Little Miami and building one of these story maps. That's a wonderful way to consolidate the data from so many different sources. I mean, I would like that just so I understand it, because I have a hard time keeping track of it all. I have a question, Adam. I thought maybe you would help me with this. The Dayton Airport is no longer supporting itself with passenger fares. The city of Dayton owns the airport. So they've decided to make it somewhat of a cargo hub with maybe light industry around the periphery on the model of the Wilmington Airport. All right, well, there is a 25-year-old restored prairie called the Nuke Prairie. And the volunteer groups that restored it love it and they treasure it. It's fully mature. Anyway, a lot of people have been involved and they have a nostalgic attachment to it. So when the city decided to put this prairie up for sale, it engendered a pretty strong citizen response. And I and my boss, Bob Gable, ended up going out to that prairie and walking it. It's almost the entire headwaters of a tiny stream called Wiles Creek, which flows through the Allwood Audubon Center and is its central teaching feature. It's cold and it always flows. The creek's about 3 miles long, flows into the Stillwater State Scenic River. That's why we were interested. And we noticed that we could not find any indication of surface runoff. No rills, no gullies, no nothing. Little research turned up the fact that prairies can absorb even a 9-inch rainfall. So I started to think of deploying prairies everywhere in my watershed that I could get people to plant them and then leave them alone, because not only do they recharge the aquifer, or allow for aquifer recharge, but they could serve as interceptor drains. Your French drain reference is what made me think of this. Because if you could put a prairie strip where sheet wash is going down, I think it could be very effective at intercepting that and pulling it back down in the aquifer. And I keep asking people in other watersheds, are you using this? Because it seems so self-evident, or else I'm missing something. And I never find anybody who's using them. Am I missing something, or is this an unexploited technique? Maybe. Okay. All right. I need an SQM coordinator. Thanks.
Thank you. Okay, so up next will be Eric from Hamilton County Public Health.
Is there someone behind me? Oh, you got it. I promise I won't go that long. Hello, everybody. My name's Eric Bartle. I work for the Hamilton County Health Department. I'm an environmental health specialist, is my job. And I work on the stormwater team. So we respond to illicit discharges inside the stormwater district. So any sort of pollution that's getting in, it could be anything. Most of the time it's sewage, because that's the main thing the health department deals with. But it could be anything. So the primary things we see are cross connections into the storm sewers. But we only have jurisdiction on like illicit discharge things when it comes to municipalities that are in the stormwater district. So Reading, Evendale, and Wyoming, for example, those aren't in the stormwater district, so we can't do enforcement on illicit discharges in them. But yeah, for the most part, what we deal with are cross connections and any sort of sewage. Normally it's cross connections from private homes that were incorrectly plumbed back in the day into the storm sewer and then discharging out to the creek. We find those all over the place. And it's kind of sad. Sometimes that's the issue we deal with, and then we work with MSD and homeowners to essentially get them fixed. A lot of the times, though, those issues come back on the homeowner because it's their sewage that's going to the creek. So, yeah, I figure we'd probably have some questions about illicit discharges. So the reason we wanted to come today is if you guys are on the Mill Creek and you see sewage getting into the Mill Creek, but it's not an MSD issue and it's coming from a private storm sewer, we'd like to know about it. So please send those our way. And then illicit discharges, there has to be some sort of evidence. It can't just be flow coming out of storm sewers. It has to be, it has a discoloration, it has an odor to it, something of that nature for us to do an investigation and figure out what's going on. So any questions? Anybody got leads for me? I figured I would have some. So was that 5 minutes? Was that good enough? Thank you.
Okay, so now I think we're ready to open it up for questions. I guess if there's any from the audience, does anybody have anything or something they would like to talk about? Really just kind of opening it up, or we can go home early. Mike Miller, yes. Oh, if you could speak into the mic so the folks on Teams can hear you.
Question for Chris Yoder at MBI or anyone else. The IBI and the ICI work beautifully on Rithron, which is flowing water, and they don't work on estuaries. And normally they find all of our estuaries in terrible condition because there's no flowing water bugs. The bugs that can't irrigate their gills, like stoneflies, ephemeroptera, and caddisflies, do not live in estuaries. However, our estuary on the Mill Creek is so viable. It's a nursery area for fish. It's got all the small fish from the Ohio River in there in July, and all the fish-eating birds come there. You see a higher density of bald eagles and egrets and even peregrines and black-crowned night herons. We fledged 18 one year in a rookery there, and also the great blue herons and the green herons. So and the kingfishers, all the fish-eating birds are there in profusion because they're eating these small creatures. Yet often these systems do not rank because we have yet to develop an IBI or an ICI score for estuaries. And I just want to ask if there's a chance we're going to see this in the future.
Got to use this. Yeah.
Expert. We got an expert.
No, that goes back to Mike when we worked at the Stewart plant. What was that creek across the river that we used? Yeah, it's a control site. And the problem is some of these are artificial habitats, by the way, due to the impoundment of the Ohio River. So we call them backwaters. They're not really true estuaries, but I understand where you're coming from. But that's always been identified as a weak point in bioassessment, both Orsanko's work on the river and our work on the tributaries, it is a gap that we haven't filled. There is a lacustuary IBI for Lake Erie river mouths that we use. So that might be a place to start. We stopped sampling macroinvertebrates in that portion of Mill Creek because we know it just doesn't, it's not working. So, but your point's well taken. They are a unique habitat, and we've known about this for decades. That's our career, right? So,
Well,
so
more work to be done.
it's a good point. All right.
Well, we had speaking of Orsenko, when I sent you an email in response to your SVP, I indicated that we would offer you an opportunity to step up and tell us something about what you're doing. So we've had a couple. We got one more, which is Bridget from Orsenko. So Bridget, please come up and tell us about what you do.
Hi, my name is Bridget Taylor. I'm an environmental scientist at Orsenko. I run it's a water quality sampling program. So we sample bi-monthly, every other month, sampling for nutrients, trace metals. And then, well, we also do other programs such as like a spill response. So if there's a spill on the Ohio River, we notify water utilities if it will impact them. We also do ODS, it's organic detection systems that are in the water utilities. So that helps detect it has raw water or high river water going through it, so it detects things in the water too. As well as the biological assessments, similar to what Chris Hall had talked about.
Thank you, Bridget. All right, well, lacking questions. You guys do stuff. Let's hear about what you do.
Shouldn't chlorides be a particular pollutant problem? Tell us a little more about that.
Chris, tell us more about that.
Well, he did say Chris, right? Yeah, chlorides are when I started my career in the 70s, it was something we just kind of disregarded. There were some of the chloride criteria that exist in the water quality standards to date are really public water supply standards for, treatable public potable water. They're not really related to aquatic life or anything else. So we have noticed that chlorides are increasing, and there is a body of research out there, and it's under the banner of the salinization of fresh water. And there's I think it's called Kaushal or Kaushal is one of the researchers that really has produced a lot on this. And he said it claims that in the northern latitudes we're increasing, our ambient waters are increasing by 1 milligram per liter per year. They're on that trajectory of increase. So this is a well-documented thing. What we do about it is less well understood because Chris said it is indelible to the environment. And what we're measuring in the summer is the leftover from what we applied in the winter. Yeah, wastewater plants are also a source. I think a lot of it's attributable to home water treatment systems, like small RO units. And where's all that blowdown going? All that TDS is getting removed. It's going down to the sewer system. And it's probably not being very effectively treated by a conventional treatment process. So the very scary option would be, well, let's do membrane filtration, and I don't think, the utilities want to hear that because of the cost. They're doing some of that in California now, though. They're treating wastewater, converting it to drinking water through reverse osmosis treatment. If I'd brought that up at the beginning of my career, I would have been fired. It was a dirty word, but so it's a real challenge. It's not a bright line toxic response. So if you go over a threshold, doesn't mean that everything's going to collapse. It's more of an indicator And these thresholds were developed regionally through the integrated prioritization system. There's an atlas of biological thresholds and stressors that there's a document that exists. I'm not sure it's on the website still or not, but that's where we grab Chris mentioned those weighted causes. We've been able to at least identify for key parameters, excellent, good, fair, poor, and very poor values. And the very poor values would relate to very poor biology. And so anything that eclipsed a very poor threshold gets a higher weighting in the cause. A poor value gets the next highest weighting, and a fair value gets the least weighting. So that's where that weighting came from. So sorry for the long-winded response, but that cleaned up a few things.
Yeah, that helped. Thank
came
you.
out.
All right, we got. Oh, yes, please.
I just that's a really big issue that needs to just be highlighted. That if you recall that bar graph I showed for the most common causes of aquatic life use impairment, it was the number 2 giant green bar. And the point I just want to point out is that was, on the headwater side. And so, yeah, this is a huge problem from the wastewater treatment standpoint, but it's a landscape scale problem because those headwaters are not where the wastewater treatment plants are discharging. That's it's a road salt problem. So, pit us against public health and see how we fare on that one, right?
Hand it off. Hand it off. Let's work our way back. All right. While you're getting ready, I want to answer we had a question in the chat that might help with what we're doing here. So we offered in a future session. So when you signed in, there was some couple boxes there. Do you want to participate in a future session? Do you want to have ideas for a future session? So we'd like to do this hybrid thing is awkward, but we are, it's just another tool that we can master. We can learn this. So we'd like to try this out, and we're going to have a Limnotech. We plan to offer up our CSO severity study as a technical program. We wanted to do that for our internal engineers. So one, they can know what we've been working on, and two, they need development hours. But we want to take that and then broaden its scope because it's a very fascinating methodology that they innovated, developed with our modelers. So we're so yes, when we do that, you'll get your email, especially if we have it, and we will then let you know, and you can join us in another future Teams meeting. That's how we'll do that. So thank you.
Great. It's Marilyn Wall, and I just wondered if you could say more about the integrated prioritization system. So we had long discussions of that in the past, and I just wondered when we have an update on that, or how you're integrating the storybook or whatever with that, or what's next.
Right. So on 2015, as part of our benchmarking study, MBI developed for us an integrated prioritization system tool that we could then use, and they delivered it to us as in 3 Excel spreadsheets. And when I brought that in house here, and the IT folks looked at it, they said, "No, we don't do that." I'm like, "Well, okay, we'll redevelop it in a manner in which you will support it because we have 600 employees and that many IT folks." So our plan in our moving forward, we have a new contract with Limnotech where we are having MBI, whose contract is ending in December, will be a sub to them. And so we're matching up MBI's work with Limnotech's skill set to rebuild the IPS tool in a manner in which that it can be supported and it can incorporate all the new data that comes in. And we can then push it out into our planning group and whatever tool they're using so that when they're going through their evaluation of projects, there's going to be another piece of that evaluation with whether the stream is impaired or whether it's needs to be protected and small stream, big stream. So all those that can be right there and be a useful tool in planning, which is kind of how it was intended. And we just weren't able to do it then. So yes.
So you'll roll it out to the public?
Yes, we'll roll it up. That's what Laura's going to do.
Good.
Yes, I do. My time is winding down here. Another person? Oh, Elena, can you give me the microphone back?
Hi, Gina Brock, occasional environmental professional, current commercial real estate agent. Thank you for having me. Got a question for you. The reason, I'm sorry I missed the earlier, so hopefully this is not rehashing anything that's already been discussed. So one of the questions that I have, if you don't mind, is that I've been following what KYTC has been doing in Covington with their negotiations with ODOT. And in negotiations with this side of the river, with the Brent Spence Bridge project and the IW and the other corridor stuff, there's large scale environmental concerns, of course, with handling of stormwater and all the problems that come along with that. And just wanted to if you don't mind, ask how you guys are addressing the future impacts of those kinds of projects, the increase of surface area, impermeable surface area for just the Brent Spence Bridge project is a 40 to 50% increase in impermeable surface area. So it's a big question. And with reading with them, my question is, with the new runoff and installing of outfalls on this side of the river and everything, how are you guys working with ODOT, and where do you see that going?
Well, that's not my project. I do know that we are working with ODOT on their I-75 rebuild, and so. Do you have any more? Yeah.
It's a little closer to mine than Chris's, but I'm not in the engineering group that can provide a full explanation. But we're working closely with ODOT in that entire corridor, and we've been doing it as they've been widening 75. So we assign a planning project manager in our engineering group to work with them as they do chunks. So I can say that there is a established project underway for the Brent Spence Bridge and the whole southern part of our service area as the bridge comes across, that they are studying right now and evaluating what impacts there will be and where that will go. So we don't have the results to tell you, but I know that we're studying it with ODOT, because when they come through town, we work with them.
Right.
We're trying to find innovative solutions to partner with them. Actually, there's pieces underway now of evaluating the impacts to the area that extends from the bridge up to about this area, and seeing if we can't partner on some projects to best handle that stormwater. It's going to affect our combined sewers, so we want to figure out a way to manage that through the existing outfalls. So you'd mentioned adding outfalls. Right now, there's nothing on the books of adding outfalls. It would be controlling it through the existing outfalls, ideally having it fully separated. And that's generally the approach, is that as much as we can, we'll further separate that into straight storm and stormwater, keep it out of the combined sewer, and trying to find, working together to find pathways to get it into the Ohio or to the Mill Creek.
So, thank you. Excellent answer.
Okay, good.
And this is just in the context of, what Covington has gotten in terms of, concessions and assistance from ODOT. That's awesome that you guys are working on that. Thank you. I guess I'm just sort of curious, will MSD at any point be considered responsible for that sort of outflow? I mean, I guess my question is, ODOT has the project as it's stated, and they're revisiting their FONSI. And with the FONSI not coming through for a while, my question is, how are you guys trying to minimize the amount of that runoff that you have to handle versus ODOT? I mean, I know you guys are working towards that, but with the FONSI not having come through, I was just wondering if you had an idea of the timeline for it.
I have no idea timeline. I know working with ODOT, they have some near-term deadlines to get design
Yes, they do.
started and working. So we are working as quickly as we can with them to identify alternatives that will benefit the whole region. This neighborhood particularly, when I say the region, because because there are several CSOs
Mhm.
and I think it's about 5 that area drain to. And they're kind of complicated underground because it's one of the oldest parts of the city. But we have it modeled and we're, collecting data on that system and have some great ideas to work with ODOT on saying, okay, more or less water, this is where it could go and how we can help.
Okay.
Timeline, I don't know. I know that there's ODOT's trying to get stuff, in the next couple of years. So that accelerates our normal design process and planning process because we need to collect the data and be able to defend our decisions. But yeah, I can tell you we're working closely with them, and the bottom line is trying to separate as much as we can. I mean, just there's if we can, we keep it from getting into the combined sewer now. Some of it already does, and we're trying to use the assets we have to keep it out.
So I don't want to derail anything. Will there be a future meeting, like integrating the concerns or the discussions with like the county that we could maybe attend to sort of explore that or hear a little bit more about that?
We can look into that
That'd be
in terms of. Sure.
I just think, I just wanted to clarify, I mean, with respect to how ODOT is managing the project, we're doing a lot with them to try to maximize the ability to do separation projects to achieve these benefits. But at the end of the day, ODOT is on their own timeline. They're in charge of their project, and they may make decisions to do things because it's quicker, faster, and maybe not even cheaper, but they have a project to deliver and say, sorry, we can't wait for MSD and the city and the county to come up with, ideas for stormwater control. So we can't drive the project. We can't really drive even necessarily public input on the project, MSD or the county but we're doing the best we can. I don't want to undercut that to try to, maximize the ability to do separation projects. But so even with respect to a public meeting or something like that, I don't know that any of us in this room really have the ability to put something like that on. I think that's.
Oh, so even working with you, that's not something that.
Well, I mean, I don't think MSD can drive that discussion. It's really going to be, we're having discussions with ODOT, city and the county. MSD is part of that, but we can't bring we could have a meeting and ODOT might not show up. So that's my point. I don't think that, not to speak poorly of them, but that's kind of how these type of projects are managed. They tend to be, they're delivering an infrastructure project. We're trying to get them to listen to potential regional, improvement and community concerns, but all we can do is try. So yeah, so I can't commit to getting them to a public meeting or anything like that.
Yeah, I was just curious if you're, working with them in a partnership, how that was going. Doesn't sound like you have a lot of say.
Well, we no, not to say that we definitely have say and we have a voice and there's a lot of discussion going on, but whether they decide to work with us or not is going to be.
Well, I'm going to pass this on to the next person.
Thank you.
Absolutely.
Appreciate that. Well, very good. So.
Related to that question, we had this discussion with the Little Miami Bridge and the east side. Bridges take more salt than anything else, and separating is going to put that salt directly into the Ohio River. Now, dilution is the answer to pollution, but the salt levels are going up in the Ohio as well as in the Mill Creek. And the salt levels in the Mill Creek are almost entirely generated by Butler County's sewage plant. I was just looking at our data from last year, 2021, and the highest concentration is in the East Fork, just below the sewer plant, and it's higher than any of the tributaries except a couple. And it dilutes as you go down river and you get more volume in. So, the point is, I think we need to go at salt from the perspective of a reduction in use. We got to find out who's using that salt and putting it in. They've got a pretty good idea who's putting it in Butler County, but they don't want to disturb any industry, so they won't touch them. But this is where we need to go. We got to have source reduction for salt, and one is salt on roads. We're doing that about as good as we can on that with a variety of technologies, but we're not getting rid of sources.
That is the future challenge, chloride, salt, dissolved solids. I think that those that follow me will be working on chlorides and total dissolved solids for some time. So there you go. And specific to water quality, that we can, anyone want to talk about what they're doing?
I think I just read yesterday that the county engineer in Franklin County is paying farmers $50 an acre to leave stubble or to actually erect snow fence to keep drifting across roads to minimize the engineer's need to use salt. Wonder if that would be something that could be done in the upper part, Butler County, for instance.
Innovative technologies, simple stuff like that. All right, we got another.
Yeah, we've got one.
You said, like in Butler County, where all the salt's coming from. Where is it coming from? Yeah. Okay.
I will remind you, this is being recorded.
Pollution footprints you'll ever see in terms of a profile all the way down into Mill Creek. I mean, I totally agree with you on that. But that and why that has been allowed to go on is who knows.
Yeah. And I'll add a little something to that discussion. Mike Miller and I and Bennett Kotler have been having some discussions with Butler County and the wastewater treatment plant folks. There is a constructed wetland project that we did years ago, just upstream and immediately adjacent to the wastewater treatment plant. And so we are trying to interest them in piping some of the water that's coming out of their outfall, but which still contains these high levels of chlorides, back up to the top of this 25-acre wetland to see if we can use natural filtration as a means of reducing the chloride. So we've had some initial discussions with them on that, still in early days, but it might help.
All right, another question from Mike. Elena, you're gonna.
A question, this goes to MSD. As you well know, you don't have to chlorinate or disinfect effluent before April and after October. Well, we sample in March and November, and we get this beautiful U-shaped curve of high E. coli at either end of our spectrum. Now, of course, the discharge is higher in March and sometimes in November, but it looks reminiscent of the fact that we're getting large numbers of E. coli from the existing facilities. And, now that we have year-round recreation on the Mill Creek, we go out every month. We're out there and we kind of like to see, the concept of potentially extended disinfection on the effluent that goes into the stream year round.
We have a all right, okay, go ahead.
We do have year-round disinfection here on the Mill Creek.
Right, now let's be clear about that.
Yeah, we do have year-round disinfection from the Mill Creek plant.
Into the Ohio.
Into,
Oh,
I can't,
those guys.
I cannot speak for Butler County, but I can speak for us here at Mill Creek. We have a year-round disinfection requirement. Yes. Yes. We just got it in online like a couple months ago. Okay, maybe it's July. Okay. And so we're still working through that. That's not covered by the permit. It's covered by our consent decree. So getting that operating and running. But we have been running that year round.
Thank you. All right, we're going to take us to the end here. We have an excellent, very technical question from Carrie Turner of Limnotech on there for Adam, and we're going to let you guys take that offline because I know Adam's going to take 10 minutes to answer that question. That's it, and we'll put it in the chat. You can go back and read the chat and the meeting thing. We'll send that to you. And we are going to make a recording of this. We are recording this, and we will. I'm going to go clean it up. So one of my things I want to learn how to do in my as I hand off all my other tasks, I'll have this task to do, and so then we'll issue out the recording so you can see it in entirety and share it that way. It'll be part of our skill building on how we can do these hybrid meetings.
All right. So with that, I just wanted to close out by saying thank you to our partners. Special thanks to Diana for being here and Reese as well. So again, hopefully, I think we're planning another one of these a year from now to go over the results of the Little Miami report. So I guess we'll see you again next year. But thank you again for your participation and have a good evening.